All right. Thank you so much for joining, you guys. Maybe, we already discussed this, but I tried for ChatGPT 4 to introduce you guys, and it failed miserably. So why don't we let the humans do it? Do you just want to say a few words about yourselves and like how you see like your work in the coming, in the coming evolution/revolution of a bunch of disruptive technologies?
Yeah, absolutely. Thanks, Alison. Hi, everyone. Thank you for coming to the panel. So I'm Marcos Allende. I'm a quantum physicist, and I've been working in the convergence between quantum and blockchain since 2017.
So I'm Haseeb. I'm a managing partner at Dragonfly, which is a global crypto investment firm. And we look at investments in all of these categories, whether they be AI, sort of metaverse, everything that intersects with crypto we invest in.
Hi, everyone. I am Cassandra. I am the CEO of Kaleidoco. We have an entertainment technology company that is building original metaverse content, utilizing innovative technologies to define the future of story living.
Wonderful. Okay, well then let's hit it off. First, I want to just shout out some numbers. When do you think that quantum computing, starting with you, can actually break encryption? What's the year that you think that's going to happen? Shout out any number. Now. Now is early. I hope not, because much will be leaked.
Hopefully not now, otherwise we're all in trouble. I hear 2030.
10 years ago. Okay. Well, we have a few suggestions here. According to Metaculus, which is a prediction platform that is really good at predicting through community predictions, it's at 2043 right now. So now the question to you is, what the hell is going to happen then? What are the risks leading up to that, and how can we prepare?
Yeah, so first of all, I'd like to give some context about what are quantum computers and why we don't know what's the day that they are going to be ready yet. So the thing is that today every electronic device like computers, smartphones that we use, they have as fundamental units of memory bits, okay? So these bits can be in a state either 0 or 1. And when we want to process information with computers, with current computers, we need to codify the inputs into zeros and ones. We need to codify the operations into zeros and ones. And we also get the outputs in the forms of zeros and ones. The thing is that now there's a new generation of computing devices that are called quantum computers that are not going to use bits as fundamental units of memory. They are going to use quantum bits, qubits. So the difference is that these qubits are something that can be in the state 0, in the state 1, and in any intermediate state at the same time. They can be in a superposition of states. So when you want to process things with quantum computers, you don't need to do it in like sequential order. You can basically do everything at the same time. You can do a kind of a superposed computing. And even the different qubits, they can be entangled, so you can basically do so crazy things with this type of devices. So the thing is that if we see the evolution of classical computers, the ones that we have today, we started with vacuum tubes, okay? And it took decades to go from vacuum tubes to microprocessors. So with quantum computers, it's the same. Today, IBM and other private sector companies in the US and also governments like the Chinese, they are developing large quantum computers, but they are still in very large devices that are not scalable. So they've been doing this for the past 25 years, and they haven't reached yet the point where they find the architecture that is scalable. The thing is that when that breakthrough happens, when that architecture becomes scalable, that's going to be so fast, and basically we are going to have quantum computers that are going to be very powerful and very dangerous at the same time. Now, going to the question. So the thing is that quantum computers, the thing that they can do very quick is basically reversing public key cryptography. So today, all our blockchain assets are protected by the private keys that we have in our wallets. But we are exposing the public keys in the blockchain because they are meant to be public. A quantum computer can see our public keys and can discover our private keys very quickly, so they will be able to basically steal all our assets. And the final thing is that when someone has a quantum computer, they are not going to probably put it in nature or put it in any way where we can discover they have a quantum computer. They'll use it silently, as for example, Enigma in the Second World War was used silently. So we need to start having roadmaps in order to make blockchain resistant to attacks by quantum computers in order to protect this trillion-dollar industry that is going to be tokenized over the next years.
Okay, so what's going to happen, do you think, when time's up and you publish a wonderful paper on what we can do right now to prepare?
Yeah, so we've been working on a while on this, and we published this paper in the Nature's magazine Scientific Reports a couple of weeks ago. And we basically proposed the first framework to make blockchains resistant to attacks by quantum computers, and we also did the first implementation. So right now we are basically proposing that every transaction is encrypted with a second signature that is resistant to attacks by quantum computers. There's some algorithms that have been standardized by NIST already. So it is important that we develop the right technology to do this in a way that is scalable, because these implementations of post-quantum signatures are still not very optimal, and it requires some work in the community to make them available for working on mainnets. So we are calling the community to work with us on that.
So I like the idea, and I think people have been talking for a long time in the history of Bitcoin about what happens when quantum computers arrive, because of course, 10, 12 years ago, when Bitcoin was in its very infancy, people were talking about this then too. And of course, no one had any idea how long it would take, and it's always 20 years away, and it keeps being 20 years away.
Like fusion.
That's right, that's right. Like AI as well, as I'm sure we'll talk about. But the hard thing is, of course, coordinating, right? Because once we all know, okay, the quantum computer is arriving next week, and so everybody needs to shift their keys over. Right now you have ECDSA that you use for signatures on Bitcoin. Now you got to use some post-quantum algorithm. And of course right now, NIST was running a competition for post-quantum algorithms, and the vast majority of them are totally broken. And of course, that's what you do with the signature schemes, is that we don't understand post-quantum cryptography super well yet. A lot of stuff is broken. That's how cryptography works, is that most of these things are not affirmatively known to be secure. We kind of have these rough arguments of why they're secure, and then somebody figures, there's actually this really weird tiny little thing you can use to break it. And that's where we are right now with post-quantum computing. And so I suspect that probably what happens is that we'll have about 5 years to go until we're like, okay, they're factoring big numbers now, it's time to start getting worried. Right now, I think quantum computers can factor 3-digit numbers, which are obviously tiny. It's less than what a third grader can do. But once you see that, this thing is really catching up, we see this Moore's Law type growth to quantum computing, then it's like, okay, everybody get in line, shift over your signature scheme to a new signature scheme. The biggest problem, though, is that a lot of Bitcoin, just looking at Bitcoin, not other cryptocurrencies for now, a lot of Bitcoin has not been touched in a decade. And that Bitcoin probably is not going to wake up and realize, oh shit, I need to transfer over my coins, otherwise the quantum computer is going to steal them. And so you're going to have a moment when a quantum computer, whoever gets the first quantum computer, regardless of whether there's a big shift over, all of the stolen Bitcoin, or all of the dead Bitcoin, will come back to life as basically zombie Bitcoin that will be owned by whoever develops the first quantum computer. And that may well be the biggest prize for developing a quantum computer, is not protein folding or all this other fancy stuff you can do with quantum computing, but just stealing all the dead Bitcoin. That you will be able to do no matter what if you develop a quantum computer.
Yeah, that gives us a nice incentive to switch ASAP once it's available. Okay, wonderful. Maybe to shift gear a bit and draw weave a few other of your guys' technologies into the mix before we try to combine them all. I want to hear from you, Cassandra, but perhaps also from all of you guys. When do you think, what year is that 1% of the global population in major cities are going to use augmented reality? What year do you think that is, roughly? You can shout out a number. At least 1% in major hubs. Okay, we have a few suggestions here. Well, according to Metaculus, it's already by 2028.
28.
So relatively soon, right? Relatively soon.
Less than 5 years. I mean, Free Guy can become a reality. So if you guys haven't seen Free Guy, it is, talking about a digital overlay on our real world with augmented reality. In today's world, over 90% of smartphones are AR capable. Which means many people are using AR, and sometimes many consumers don't even realize they're using AR. So there is more of an adoption happening than we've ever seen before because of this movement with the technology. You're utilizing it in your social media, retail, education, gaming. These are going to be kind of our first movers in kind of people actually getting used to this technology and utilizing it in their everyday life. So there's a lot of opportunity with AR.
Yeah, well, I think what was super interesting about your work is that you really are also trying to kind of weave in machine learning a little bit more, into the mix to actually create very kind of contextually rich environments for folks. And I think, given that we've just heard the AI Doom talk, I'd be super curious about some beneficial applications for this stuff.
Yeah, so what we're doing when we talk about contextual awareness, right? So and when we talk about defining story living, that's talking about utilizing machine learning and incorporating that into augmented reality. So for instance, imagine you've got your little AR character. It's hanging out. You can actually converse with that character. That character can, respond to you in accordance to the environment that it's around. Then you have this kind of casualness with it. All of a sudden, it feels a little strange at first, but there's a free-flowing conversation, right? A lot of us are having this now with ChatGPT. So we're kind of like, oh, people are getting used to asking it questions. Oh, you know what? Well, let me go and find out what ChatGPT says, right? So we're already seeing this with ChatGPT. Now imagine the AR character. That AR character, understanding its environment, your feelings, the context of your words, becomes your companion. And all of a sudden, it's living with you. And all of a sudden, it doesn't feel so much like a digital character anymore. It feels like your companion, your sidekick. So this is where we're talking about creating digital empathy, about story living, and those characters not only being something you can game with, but they're also educating you, they're teaching you, they're guiding you, hopefully, to make better choices in life, because they're also being able to access the information on computers, the way that LLMs are with ChatGPT, to understand how to make better decisions. So these are ways that we incorporate AR and ML to create this kind of very visceral and contextual richness in this technology.
Wow, I already see next year at Consensus, we need extra tickets for the AI versions that we have with us. But do you think if you just pinpoint to folks, what are a few frontiers in this technology that you see that are currently open, where if someone was excited about this stuff, how could they help make progress?
How can they help make progress?
Yeah.
So the biggest thing is about making this seamless. So technology-wise, so it's object recognition, it's scanning, really bringing the, working on these types of technology to kind of help understand, first from the hardware perspective, software perspective. It's all still very much in its infancy. But it is, becoming something more kind of simplified. So, Instagram, where people are kind of scrolling through, all of a sudden you're like, oh, that's a pair of cool sunglasses. All of a sudden it's on your face, you're like, whoa. So that's where we're seeing the consumer adapt to it. But we want to be able to have more of that interaction, so hand tracking and other things, so computer vision. But one of the other big things when we talk about machine learning and AI, obviously, is security and data privacy. So yes, it is learning about our world around us, but we need to figure out ways to actually make it more secure as well, because your privacy is important. We want to enable our lives to have a better and easier flow to them and utilize this technology in the right way. But it's also important that we are able to have agency in how it's used and the data that is being shared.
Yeah, wonderful. That also ties in nicely with the talk just now on really perhaps leveraging more cryptographic technologies and the way that we really create these ARs. Okay, wonderful. Well, that brings us also to you, Haseeb. I think it's a really nice segue. I already asked you guys the question on when you think that AGI will hit, so I'm not going to repeat this kind of audience Q&A now. But I want to hear from you. Metaculus thinks it's 2030 right now. How do you see kind of the path from here towards AI pan out? And what kind of technologies do you think could crypto really help advance within that kind of I guess a few years that we have left to make these systems safe?
It's a good question. So I think if you look at the rise of large language models, which I think is what most people think about when they think of oh shit, AI is getting crazy. It's very clear large language models are going to be very broadly used in basically every industry. And I'm sure, how many people actually in the audience use ChatGPT? Okay, basically, almost everybody. The thing is, I think what you're seeing, you're already starting to see companies ban ChatGPT because they're realizing that, oh shit, our people aren't even reading what they're sending in emails anymore. At this point, huge parts of the economy are going to start getting outsourced to large language models, and you're going to start seeing it really affecting productivity. The effects on productivity are going to be very broad-based. They're going to affect every industry. And in that way, they're obviously going to affect crypto because you're going to need less engineers to write the same amount of code. You're not going to need the same amount of testing. You're not going to need the same amount of copywriters, marketers, advertising, all that kind of stuff. Especially when it's text in, text out, there are a lot of jobs that are basically being a large language model. And if that's your job, then you should be worried. And I'm sure people have varying degrees of what they do day to day. That's basically reading text and then spitting some text back out. It's very clear these things are getting better really fast. The question is, one, how is this going to affect crypto? And then two, what is crypto going to do back to AI? So the first part of that question is, what is that going to do to crypto? I think it is going to lead to much more innovation in crypto, because it just means that it's going to be easier to build stuff with less resources. And obviously, that's a boon to any area that's capital efficient. And because crypto, you just need kind of somebody write some code and then get it audited, and then good, you're ready to deploy. Crypto is already naturally very capital efficient. That capital efficiency is going to explode as these large language models get better and better at writing code. And code is what they're great at, right? They're bad at creativity or like coming up with novel ways of doing something. But if it's just like, hey, I have this idea implemented in code, it's exactly what GPT-4 is great at. So I think that is going to lead to a lot more products getting built, a lot more smart contracts getting shipped. It's going to lead to even things like auditing getting cheaper, because that's the kind of thing that a large language model is going to be good at, is reading code and figuring out, you made this mistake, this is a common error, blah, 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 blah. So those are ways in which crypto, I think, is going to become empowered to some degree in obvious ways, just in the sort of supply chain or talent pool of the crypto world. Now, how are products going to change in crypto? I don't actually think there's going to be that many changes on the product side from large language models, right? There are things like, okay, well, if you want to query some data, now you can express that in natural language as opposed to going on Dune and writing a SQL query or paying an analyst. There are things like that that are going to become much easier. But crypto in general doesn't involve that many language tasks. Crypto is not a language-heavy kind of area of life. It's very financial, it's very code-heavy, but beyond that, it's not that much about language. So the place where I think crypto and AI are going to interplay is going to be more in the area of when we start seeing AIs that are more like agents. So today, if you look at something like ChatGPT or GPT-4, we sort of make them play dress up. We sort of make them pretend to be people or to pretend to be agents, right? We sort of say, oh, yes, sir, I will do your bidding. Whatever your wish is my command. We want them to act like that. But the reality is that these things have no memory. They have no persistence. They don't really even have goals. All they kind of do is just continue a sequence of text, right? That's all that they do currently. But people are now starting to come up with formulations to make them more like agents. Things like AutoGPT, things like BabyGPT. These are the very first kind of crude ways to make these things act more the way we will eventually make them act, which is as agents in the world doing things, accomplishing goals on our behalves, ideally on our behalves. And once you have that, then one thing that you can draw a very straight line is that AIs are going to use crypto to pay each other and to pay people. Why are they going to use crypto and not use fiat? Why are they not going to use other forms of money? Well, I'll tell you, because an AI cannot open a bank account. Okay? Nobody, like Chase doesn't allow crypto startups to open bank accounts. They're definitely not going to allow AIs to open bank accounts. And so the only way that AIs can bootstrap without waiting 5 years for people to rewrite regulations and rethink all of the laws and regulations that assume that you're either a human being or a corporation to own money, AIs are going to bootstrap way too fast for regulations and lawmakers to catch up with thinking about what is the right framework with which to let these people get access to fiat money. Agents are going to they're going to leapfrog all of that and say, well, I'll just take USDC. I know how to manage a private key. I know how to interact with APIs. I can interact with crypto, no problem. And you're going to see agents interacting with each other and interacting with humans through crypto being the form of money. That, I think, is going to be the most immediately crazy and probably scary intersection of crypto and AI. And I would guess that we're going to see that within a year or two, to be honest. But it's going to accelerate probably over the next 5 years.
Wow.
Yeah, I was going to say, I mean, like, there's a lot of risk to these immutable, agents that can, like, ram amok paying private crypto. That's, like, definitely something to at least pay attention to. Okay, wonderful. But getting off the doom and perhaps like onto a more existential hope track, I would love to see what you guys have to say about the technologies of each other. In particular, do you see any like positive futures in which like quantum, AR, and AI like interact pretty richly? Like, is there any kind of like patchwork that we can draw here? Like, just in terms of timelines, like if quantum computing can only break encryption in 2043 and we have AGI in 2030, that's not really going to work out. Like, yeah, how do your futures mesh?
Yeah, so I have this personal belief. So one of the reasons why I started studying physics, it was because I wanted to understand how stuff works, and particularly things like consciousness. So there's this, this theory that there's, this is actually something that is factual. So there's 4 stages where you can classify AI. One is reactive AI, basically like your Alexa. The second one is a limited memory AI, like a self-driving car. And then you have a theory of mind AI that is basically what we are getting with ChatGPT, like chats that can pretend they think like humans. And there's a 4th stage that is self-conscious AI. So AI that can develop some kind of consciousness. So the thing is that today we don't know how consciousness works. Like there's these theories, and this is the theories that I was talking about, that say that there's like quantum phenomena, like this superposition and entanglement that I was talking about when I was describing quantum computers. So those quantum phenomena, some people believe that they are at the basis of our consciousness. So my personal belief is that there's going to be some moment with the evolution of AI that quantum computers are going to be ready to actually provide the machines to generate AI at that level of quantum phenomena. So maybe at that point in time we will have like machines that can have self-consciousness because they are running algorithms using quantum computers. So that's what I'm excited and worried about at the same time.
Wow. Orchestrated objective reduction. It's a highly contested theory. Let's see if it pans out. Hopefully, we will find out once we query them. Yeah. What would you say?
Yeah, I think it's pretty clear that AI right now is this kind of industrial revolution type technology that's just going to accelerate everything else if it works. It's obviously possible that we hit some roadblock and we say, oh, we have large language models for like 8 years, and they get kind of bigger and nicer, and they're more fluffy, and they act more like people. But for the most part, like we kind of are basically at human-level intelligence plus Google access for a very, very long time. That's possible. But it seems more and more likely that things are moving really quickly, and it's pretty hard to anticipate where this is going. I think it's pretty clear that once you have AGIs, artificial general intelligences, that are superhuman in their intelligence and in their creativity and their ability to solve problems and to interact with the world, that's going to be accelerant for every other technology, because ultimately technology is, in our world, is gated by R&D. And once AIs can do R&D, and they can do it better than us and faster than us, then it's very difficult to predict how that's going to affect other technologies. So my assumption is that AI is the thing that kind of makes everything go haywire. It makes it very difficult to predict how other technologies that are adjacent or even will take longer than the timelines for AGI, how they are going to end up playing out. Because AGI, the distribution of outcomes is so wide of what could possibly happen once you see intelligence really start to take off beyond human levels. So right now, it's just so hard to predict how these things are
going to
happen.
Hands up in the air. Well,
Basically.
Cassandra, leave us with some hopeful words here.
I mean, wow. It's the blending of these technologies, right? And so I think quantum computing, AGIs, well, we're talking about, augmented reality, virtual reality. We're all kind of seeing the beginnings of this, right? So, and kind of how the potential intersections and what these opportunities provide, and also what could be kind of frightening to an extent as well. But I think there is a lot of positives that can come out of it as long as we're creating awareness, we're educating each other, we're being proactive. So I do think in the realm of also utilizing technologies like AR and VR, quantum computing obviously eventually is going to make it faster, easier, make live immersive experiences more real. Obviously AGI, and as we're talking about this, as the AI is understanding more and more of our world and becomes this kind of superhuman, becomes kind of our assistant and our best friend and our guide. So there is a lot of positive that comes out of this, but there's also a lot of awareness that I think needs to be just cautionary.
Absolutely. Well, we'll leave it on this kind of hopeful note. Thank you so much, guys. This was really, really fun. And yeah, now it's up to you to build the futures that we just dreamed up here. Thank you, everyone.
Thanks, Alice.
Thanks, everybody.
Thank you.